While in school, we have all learned that there's a special type of functions called logarithmic functions. You know that log 10 is 1 and log 1 is 0 and log 100 is 2. We have all been taught about this and we have all been asked to memorize this, but nobody really taught us what do these logarithmic operators even mean. So let us focus on that. Logarithmic functions are inverse functions of exponential functions. When you take an exponential function, you have base, let's call it a, and you take an exponent, let's call it x, which is going to be also a variable of this function, exponential function, a to the x. This is going to be an exponential function where we know we have already been given a base, and the variable we take is the number that our base is going to be raised to. So what does this mean is this is a times a x times. This function gives x as an input and gives us the output of a constant. Let's in this case that is a raised to that input. This is the output. And logarithmic functions are exact inverse of this, exact opposite of this. Logarithmic functions, these two have also this constant inside of them, and this time this constant is also called the base. But inside of the input, it takes this output value as its input. So basically what does that mean is that log to the base a of a to the x gives us x. Why? Because this original exponential functions, what does this do is, it asks us a question like what is a raised to the x, and the answer to that is a to the x. But a logarithmic functions asks the opposite question: what power should I raise my base to get to this answer? You can remember the BAP rule for this. BAP, base answer power rule, and it asks us we have an answer, we have a value, and we have a base, and we want to find out a power that we can raise this base by to get this answer. Instead of the answer, we have, or you can call it the input value. We have a to the x, and log base a of a to the x gives us the power that we need to raise a to get a to the x. So of course, the power that raises a to the x is of course gonna be x. So there should not be any doubts regarding that. And this is where logarithmic functions come into play. Most of times you have seen logarithmic functions like this. The base is not mentioned here. If the base is not mentioned here, uh, you will need to remember that actually this has 10 as a base inside of it. This is why log base 10 of 100 is 2, because it asks us that which number should we raise 10 to get 10 by to get 100, and that is of course going to be 2, because 10 raised to 2 is 100. The same way, if we plug in 10 inside of this function, we would get 1, because 10 raised to the 1 is 10. If we had 1, we would get 0, because only raising 10 to the 0th power gives us 1. Okay,